I want to see how you can think through. Is that which vector best represents the resultant of concurrent forces A and B in the diagram that follows? So you have this vector, vector A, and then vector B. These are termed as concurrent. Please let me take this coin and get back to the class. Concurrent vectors are vectors that occur or act at the same time, concurrently. Okay, so while A acts at the point, at this point, B acts at the same point at the same time. Hence, we say A and B are concurrent forces or vectors. Please, that's okay. So these concurrent forces, vectors A and B, act at a point. Out of which of the following represent the resultant of these two concurrent forces or vectors A and B? Yaba, it's your question. Yaba, will it be 1, 2, 3, or 4? Yaba, are you there?
Yes, please. I'm solving.
Please, the rest of you must also solve. So, in case he gets it wrong, you can also be in a good position to answer. Yaba, your time is up. Oh. It's a quiz question. 15 seconds. What's your answer? Is it 1, 2, or 3, or 4? Okay, let's pick let's pick on
One.
somebody. It's 1. Okay, please. Apart from Equiadoma, do we have an alternative view? At a Yaba is saying is the option 1. Do we have any alternate view as to which one is the resultant? Lizzie, do you have any? Okay, then because of time, let's see. All right, so if I have this vectors A and B acting concurrently, how do I determine the resultant? First, I have to resolve this into a parallelogram of vectors by applying equal vector approach. So I create an equal vector of this and put it on the head of A. So I have this. Same magnitude, same direction. Then create, so this is also B. Then create the equal component of A and place it on B. Same magnitude, same direction. Okay. Now look at the directions of the vectors. B this way, A this way, A this way, B this way. So it means that the resultant will be drawing a vector from here to this point. So this will be the resultant force. So looking at the possible answers, Yaba, did you get it right? Yaba, did you get it?
Yes.
Yaba, yours is 1, and your option goes downwards. Your answer goes downwards. So the obvious answer must be 3, because the third answer goes upward like this, and it represents this. Please, class, are we okay with the answer? Are we? Hey, the class is quiet today. You are not giving me any feedback. Why?
Yes, please, I'm having a network problem.
Okay.
Please, me too.
Instead, I
All right.
just joined. What's going on?
Those of you with a good network, give me feedback. Question 2. Question 44. What is the magnitude of the vector sum of the two concurrent forces in the following diagram? So we have two forces acting perpendicularly to one another. This force is 2.0 Newton. This force is 1.5 Newton. What is the magnitude of the
Yeah.
of
Instead,
these two? Yellow.
please, the question I was answering was 44.
Okay. So we are answering it in that order from 43, 44, 45. Okay. So we are on the 44 now. We are to determine the magnitude of the resultant. So start with quickly. I'm giving you maybe 1 minute is even too much. 1 minute. Quickly do it and then tell me the answer. Yeah, Bushra, I'll take your answer. So be ready. Okay, so this vector is or force is perpendicular to this. We are determining the magnitude of the resultant. One minute or so. Yeah, Bushra, what's your answer? Bushra, what's your answer? Question 44. Pardon?
Please, it was
What is it? Is it option 1, 2, 3, or 4? Which
please
is which?
2.
2.
Yes, please.
2. Do we have an alternative answer or view?
What is it? 1, 2, 3, 4.
Do we have a different answer?
Say please 1.
So yes. So the answer is 1.
Please, please, 1.
Yes, the answer is 1. So this will give you, if you resolve this, you have an equal vector 2. This is 1.5. So when you look at the directions, this becomes the resultant. So the resultant, we have to use Pythagoras theorem. 1.5 squared plus 2 squared. Okay, this is 4 plus 2.25, giving us 6.25. And so R is the square root of 6.25. Listen, mute yourself. Okay, question 45. Question 45 goes to Elikam. Elikam, are you there? Alikam, are you there?
Yes, please.
Just give us a wave offering if you are there. Okay. Alikam, question 45. The resultant of two concurrent forces is a minimum when the angle between them is it 1, 2, 3, or 4? The resultant of two concurrent forces is minimum when the angle between them is it the option 1, 2, 3, or 4? Elegant.
Mr. Adia, please, I think it's 3.
3, 3, 3, 3, 3. All right. Any different opinion? So we judge.
I think it's 4.
Okay, my opinion. The resultant will be of two concurrent forces is minimum when the angle between them is 180. So it's the fourth answer. Charlotte, are you okay? It's the fourth answer. Question 46. So, but which angle will give us a maximum resultant? Which angle would give us a maximum resultant?
90.
Pardon? Yes, come again. Which angle would give us a maximum resultant?
90 degrees.
Okay, Nanekia is giving us 90. More views. Maximum resultant. Hey, more views.
90.
0, 90. The maximum resultant will be when the angle between them is 0. Okay, when the angle between the forces is 0, it means the two forces are parallel, moving in the same direction. Here, the resultant is addition of all of them. When they are 180 apart, the forces are like this. One force points to this direction, the other force points to this direction. And so here the resultant is when you subtract one from the other. Okay. Question 46. Question 46. Which vector best, please, those of you who just joined, the question is on the platform. Or the questions. Okay. Question 46. Which vector best represents the resultant of two vectors in the following diagram? Which vector represents the resultant of, we have two vectors acting at a point, they are all acting at a point P. Okay, so which vector from 1 to 4, which one of them represents the resultant of these two vectors? Let me bring the arrow this way. Good. So from 1 to 4, which one of them represents the resultant of these two vectors acting at the point P? If you are ready to share what you got with us, you can freely own up. Eresi,
Sir, please, 1.
1. More views. Yes. If you
4.
have any, Watman,
Instead, I think 4.
you think 4.
Please, I think
Yeah. You think 2. Lizzie?
1.
All right. Let's see. What do I also think? I'll draw the equal vector of this, place it on this. So vectors are equal when they have the same magnitude, direction, and are parallel. Equal vector of this same magnitude, same direction. So no matter where I take it, or this, the resultant points to this direction. So this must or qualifies to be the resultant of these two vectors. So looking at the answers, I think the obvious answer is 1. The obvious answer is 1. Please, are we okay? Are we okay?
Yes, please.
Question 47. Question 47. Agree about this is your question. As the angle between two concurrent forces of magnitude 5 newtons and 7 newtons increases from 0 to 180, the magnitude of their resultant changes from, is it 1, 2, 3? So start with, as the angle between two concurrent forces of magnitude 5 newtons to 7 and 7 newtons increases from 0 to 180, the magnitude of their resultant changes from, I'll pick. Okay, let me leave it to whoever is ready. If you are ready, share your opinion with us. What is your answer?
12
Said you are-
newtons to 2 newtons.
So as the angle changes from the magnitude of the forces, two concurrent forces are 5 and 7. As the angle between them increases from 0 to 180, the magnitude of their resultant changes from, but what did you say?
12 to 2.
12 to 2. Okay, that's your best view. And she is saying the option 3. Yes, more views.
said you
More
are
views.
12 to 2.
12 to 2. Yes, 12 to 2 is the answer. The forces are 7 and 5. So as the angle between them increases from 0 degree to 180 degree, the resultant will also change from 12 to 2, because when it's 0, the resultant is determined by adding the forces. When it's 180, you have to subtract the smaller force from the larger force. So it will be 12 to 2. Question 48. Which pair of forces, concurrent forces, may produce a resultant of 20? Which pair? From 1 to 4, which pair would produce a resultant force of 20? 20 Newton. Yes. Yes. Which of them would produce a resultant of 20? Lauren, help me. Which of them would produce a resultant force of 20? Yes. Anyway, if you are ready, share your answer with us. Which of them? Will it be 1, 2, 3, or 4? Hey, the class is quiet. Okay, I think the option that will give us a resultant force of 20 is 2. The second option, where the individual magnitude of the forces are 20 Newton and 20 Newton. Why? This is the reason. It may not be exactly 20, but that option is close to 20. So 20 Newton and another 20 Newton. Now, when the forces are in the same direction, meaning the angle between them is 0, the resultant will be 40. When the angle between them is 180, the resultant is 0. Now, what about if the angle between them is 90? Will that give us a resultant close to what the question says? So let's see. So this would obviously give us a resultant of 20 squared plus square root of this and that, okay? This is 400 plus another 400, giving us root of 800. Okay, so we have root of 8 times 10, and this is 440 times root of 2, and root 2 is 1.414. Multiply 40 by 1.414. Let's multiply 40 by 1.414. What will be the result?
56.56.
So that will be the closest. Okay. So that option would give us an would produce a resultant which is close to 20 Newton. Question 49. In the following diagram, which force could act concurrently with force A to produce force B as a resultant? So we have force A. Force A is in this direction, A. And the question, early time, your hand is up.
Mr. Adia, please, I wanted to ask a question on a previous question.
All right, go ahead.
Please, when you put root 800 into a calculator, you get 28.284.
Yes. Yes,
But
what
you
I'm
got
saying, finish. Go ahead and finish.
but your final answer was 56 point.
No, what I'm saying is that, you see, when you determine the square root of this, say you have 26 point something. Okay. What I mean is that if you look at all the pair of concurrent forces, the one that will give you a close value of 20 Newton is this pair. Okay, is a 20 Newton forces that will give you a resultant close to the 20 out of the 4 options given. Alikam, are you okay?
Yes, please.
So we are looking at the pair that will give us the closest value not necessarily exact, but the closer value is what we are looking at. In the following diagram, which force could act concurrently with force A to produce force B as a resultant? Force A is in this direction, and we are talking about which one would act concurrently on force A to produce force B as a resultant. This is force B. The direction of force B is this. Out of the 4 vectors provided, which one of them? Oh, I think the fourth one isn't so clear. The direction, shit. Okay, so you will test the 3. If none of the 3 works, then it's the fourth one. Okay, so which of them, when acted on A, would give us a resultant of B? Will it be 1? Will it be 1? Will it be 2? This is 1. If we place 1 on A, let's see if 1 will give us a resultant of this. So I have to resolve this. Same magnitude, same direction, and then it must be parallel. Then if I place A on this one, I have this. Looking at the direction, this, or this. The resultant, when I place 1 on A, doesn't look like B. So the first vector is out. Okay, please, I hope you are following.
Yes, please.
Okay, so let's test 2. Let's test 2 on A. A is still in this direction. The second option is like this. It's like this. In this direction. So if the second option acts on A, will it give us a resultant of B? That is what we have to look at. So
Yes, please.
equal vector of this, same magnitude, same direction. Then so if when we look at it, this is also A, this, the resultant is in this direction. And this resultant resembles B. So the correct option will be the second one.
2.
All right. It's the second answer. Let's see why the third will not work. A is still like this. The third one is horizontal, points in this direction. And once it points in this direction, the resultant would be along the diagonal. And this doesn't look like B. So the second option is the correct answer. Please, is that understood? Question 50. Question 50. 3 forces of 10 newtons, 8 newtons, and 6 act concurrently on an object in equilibrium. The resultant of, okay, here because we haven't treated equilibrium of forces, I'll solve this. Let's move on to question 51 and 52. Into how many possible components can a single, into how many possible components can a single force be resolved? Into how many components can a single force be resolved? Is it an unlimited number? Is it 2, 3, or 4? Into how many possible components can a single vector or force be resolved? Yes,
2.
2. Okay. Last week we realized that even a vector along the xy plane can still be resolved into 2, even though one component will be 0. So 2. All right. 52. A lawnmower is pushed with a constant force F, as shown in the diagram. As angle theta between the lawn handle and the horizontal increases, the horizontal component of the force, will it increase, decrease, or remain the same? This is what the question seems to be testing. This is the lawn. Let's take this to be a force. A force is the lawn is being moved. Okay, so let's take this vector to be a force exerted on. Now the angle between the lawn and then the mower handle, theta. What the question is saying is that as we increase theta, the angle between the lawn and then the mower, will the horizontal component of this force increase or decrease? That's the question. Yes, think through within a minute and then give me feedback. So as angle theta between the lawnmower handle and the horizontal increases, as theta increases, the horizontal component of the force F, will it increase, decrease, increase, or remain the same? If you are ready, share your answer with us. Whoever is ready, give us reasons as to why you are settling on an option.
Mr. Dia.
Mm-hmm.
And please, the question 52, the rest that you were reading, I don't have it here.
Really?
Yes, it only enter where the diagram is.
Let me check. Okay. So as theta increases, okay, I've sent that to the platform. So as theta increases, as angle theta between the lawnmower handle and the horizontal increases, the horizontal component of the force, will it decrease, increase, remain the same, or remain the same? Yes.
Mr. Adria,
Yes.
Mr. Adria, please, I think the horizontal components will increase. This is because the horizontal component is equal to the resultant force times cos
Theta.
times the angle of projection.
Cos theta, yes.
So since the horizontal component is directly proportional to the angle, if the angle increases, if the angle increases, the horizontal component will also increase.
But then, in the same way, this is what you are saying. This component fx is equal to this. The vertical component is also fy equal to f sine theta. So, Amma, if you are using proportionality, it doesn't explain it well, because this is also the sine of the angle is also directly proportional to the vertical increase, vertical component. Meanwhile, as theta increases, one would increase, one would decrease. So here, what you have to do is that let's take theta to be 30, then we increase it progressively. Okay, so initially take theta to be 30 degrees, then when you finish, take theta to be 60 degrees. Okay, meaning that it can be, the jump is even, it can be 45, 30 to 30 degrees, 45. And use that in the equation to see whether this will be increasing or decreasing. The horizontal component will be increasing or decreasing. Please, I hope you're okay.
No, please.
Aren't you okay with the explanation?
No, please.
The question is asking, as theta between the loan, there's a loan on the ground, and then this is the loan handle. The handle of it, yes. So whoever is pushing it, loan is pushing it from this angle. Okay. So this is the handle. Now as theta increases, okay, between the loan and then the loan mower handle, what happens to this component? Will it increase or decrease? Now, what the suggestion I'm giving you is that use increasing values of theta, and you see what happens when theta increases. So, if theta is 30, we have fx giving us f cos 30. Okay, what is cos 30? Cos 30 is 0.86. So it means that this is 0.866 f. Okay, f is constant. Now when theta increases to 60 degrees, we'll have fx giving us the f cos of 30 degrees. Oh, it's an increasing thing. So let me begin with okay. This will still give us 30, and then the next one is 60. So if assuming theta is 60, we have f cos 60. And what is cos 60, class? What is cos 60?
0.5.
0.5.
Good. So this is 0. This will give us a result of 0.5 f. So as theta between the loan and then the lawn mower handle increases, the horizontal component of f, will it increase or decrease, class?
Decrease.
Will
It would
Decrease.
it will decrease because f is constant. Whether for f is constant, whether the angle is increasing or decreasing, f is constant. So the coefficient to f 0.866. Now we have 0.5, meaning that if theta increases to, if theta is equal to 90 degrees, we will still have f cos 90, and cos 90 is 0. okay, making the horizontal component to be 0 completely. So as theta between the lawn and then the mower handle increases, the horizontal component would be decreasing. What do you think will happen to the vertical component of the force? Test it with the same principle and tell me what will happen. What will happen to the vertical component?
It will increase.
It will be increasing because if we are increasing it, okay, sine 30 is 0.5, sine 60 is 0.866, and then sine 90 is 1. So you realize that that component would also be increasing as we increase theta. Am I okay?
Yes, please.
All right. If you have any question, ask. If you have any question. If you don't have any question, then let's look at, we looked at resolution of forces in our last meeting. Let me give you, let's apply that in solving problems. Just 1 or 2 questions under that, and then I'm coming. When I get, I'll forward a question on the platform. I'm coming. Give me few minutes, 1 or 2 minutes to retrieve this. Okay, so a quick search. The mass is 2.0 kg. One force acts on the box horizontally, F1. This magnitude is 3 Newton. Then there's another force. Making an angle of 30 degrees with the horizontal. The magnitude of this force, F2, is 10 Newton. The question is that we are to determine the magnitude of the acceleration and the direction. This one is under forces. I don't know if there is a need of us to discuss or we should solve it. What do you think? The question is actually under vectors, okay, but it is question on forces. Yes, a force is a vector quantity, but we are treating the foundation of vectors. Then after that, we apply. Do we solve this? Do we solve it? The buttons and Eldoma, do we solve it? And the rest of you. Hey, everybody is quiet.
Yes, please.
Yes, please.
All right. Okay. Now, this question is like when an object is tied to, it is a box and there is a thread pulling it at an angle. Okay. So this is the string or the thread. F2 is the force applied within the thread or the string. The string is an angle of 30 degrees with the horizontal, maybe x-axis or the ground. Now, there's another force opposing the movement. So whilst the body is being dragged in this direction, there's another force opposing it in the opposite direction. I guess this force F1 can be friction. It can be friction because frictional force always opposes the relative motion between two bodies. Now, once this force acts at an angle, it means it will be divided into two components. The horizontal component, which is given by F cos 30, okay, and then the vertical component given by F sin 30. Okay, so by virtue of this string acting at an angle of 30 degrees to the ground, the force applied, F2, is divided into two components, a horizontal component and then a vertical component. Okay. Even though we have this diversive component, but the body still moves along this direction. Okay. Now, what is the effective force in the direction of motion of the body? The effective force moving the body okay, supposing this frictional force is not there, then the effective force pulling this body would be the horizontal component of F2. So supposing there is no opposing force, the effective force which is dragging the body along will simply be the F2 cos 30 component. Please, are we okay with this? If there is no opposing force, the effective force would only be the horizontal component of the force F2. So here it will be straight away be equal to 10 cos of 30. And since cos 30 is 0.866, the effective force dragging the mass would have been 8.66 Newton. But there is an opposition. There is an opposing force with magnitude 3. So this is moving, the body is moving in this direction, but there's another force opposing it in the opposite direction. So when you find the difference between this and this, which we call as the net force, the net force is also the resultant force between this and this, the horizontal. The net force will be F2 cos 30 minus F1, which is this is 8.66 minus F1 is 3. So we have 5.66 Newton to be the net force. So this is the force which is actually pulling the mass horizontally. The net force is the force which actually pulls the mass along. Please, class, are we okay?
Yes,
Please.
Now, the question requires the acceleration. A body can only accelerate when there is a net force, when there is a resultant force, or when there is an unbalanced force. 3 ways. So whenever there is a net force, a resultant force, or an unbalanced force, body accelerates. Okay. Body does not accelerate when there is no force acting on it. So when the force, external force acting on it is 0, there is no acceleration. The net force or the resultant force or an unbalanced force acting on a body is 0. There is no acceleration. But so long as the net force is equal to 5.6 or it's not 0, there will be acceleration. So if there is a resultant force, body accelerates. Body or particle accelerates. So yes, there is a resultant force given by this amount. What will be the acceleration? By Newton's second law, any force, whether resultant, net, or an unbalanced force, any force can be measured by the mass. Any force on a body can be measured by the product of the mass of the body and the acceleration of the body. Okay, and so our resultant force is this. So we have 5.66 is equal to the mass of the body is 2. 2 times A. So A is equal to 5.66 divided by 2, which is
2.83.
2.83 meter per second squared. Body's acceleration always occurs in the direction of the resultant force. Resultant force is always in the direction of the larger force. So here the contrast is between the effective force to this side, the 8.66, and it's opposed by 3.0. So 8.66 is a larger force. Okay. And so the body will always accelerate in the direction of the larger one. So the direction of the acceleration is to the right. To my right, and I'm sure to your right as well. This is the problem of the day.
So, Mr.
Okay.
Jia,
Hello.
Mr. Jia, please. So, the last statement you made, that's what we're supposed to write.
Yeah. Yeah. After identifying the direction of the yes, after identifying the magnitude of the component, okay, because this component, the horizontal is this, that the body would accelerate in the direction of the larger one, so to the right. Okay. A 10 Newton force. A 10 Newton force gives a mass m1 and acceleration a. So do I clean the board? Do I clean the board? Okay. Silence means clean the board.
Mr. Dia,
Hello.
please, the question said we should find the direction of the
Oh.
acceleration. So says out there 2.83 meters per second square that we found.
The magnitude of the acceleration is a 2.83 meter per second squared.
Tell about the direction.
The direction is what I said. The direction of the
Pardon?
acceleration. The direction of the acceleration will be it will be to the direction of the larger force. Okay, we had
Okay.
8.66 as the force to the right, and then the opposing force has a magnitude of 3. So it will act in the direction of the larger one to the right.
Okay. Thank you very much.
Welcome. Which are you there? Which is missing? Question. A 10 Newton force. So look, F1, we are told 10 Newton. A 10 Newton force gives a mass M1, an acceleration A. Now a 20 Newton force gives another mass. So F2, this is a different force. So F2, 20 Newton, gives another mass M2, the same acceleration A. What is the ratio of the masses? Okay, so from Newton's second law, any force is determined by the mass on which a force acts and the acceleration, the product of these two. Now F1 with a mass M1 would accelerate by this amount. There's a new force, F2. So F2 will also be equal to a different mass, M2. But we are told the acceleration in each case is the same. So A. Okay. So if we take the ratio of maybe this equation 1, equation 2. So F1 on F2 to be M1 times A over M2 times A. The acceleration in each of the equation is the same. So this and this will cancel out. The forces, we have 10 Newton as against 20 Newton. Therefore, M1 on M2 would be equal to 1 over 2. So the ratio of the masses M1 is to M2 is equal to 1 is to 2. That's the ratio of the masses. 1 is to 2. A fixed Newton force and a Newton force acts concurrently on a box located on a frictionless horizontal surface. Which top view diagram shows the forces producing the smallest magnitude of acceleration of the box? Which top view diagram shows the forces producing the smallest magnitude of acceleration of the box? Yes, let me pick the view of one of you. Araba, I'm on you, Araba. Which top view diagram would give us or would produce the smallest magnitude of the acceleration of the box? Araba, what is your view? Will it be A, B, C, or D? Araba, are you there?
Go and
Okay.
come.
Araba should go and come in.
Yes, yes.
Araba go where and come. Okay. Let me have Lizzie. Lizzie, which diagram will produce the smallest acceleration? Don't forget the clue is that
C.
acceleration
I think
acceleration
D.
goes. You think D?
Yes, please.
Tell us why. Lizzie, tell us why.
Mr. Diapis, it wasn't me. Someone said D.
Okay, that someone should tell us why she picked on D.
Because the angle between the forces is 180.
What you are saying is that with your choice, D, the angle between the forces is 180. So if the if the angle between the forces is 180, what happens? Or what must happen? What must happen?
It gives the smallest magnitude as compared to the rest of the angles.
Exactly. Exactly. Force acceleration goes with the force applied or the net force acting on the body. So F is directly proportional to A, or A is directly proportional to F. The larger the force acting on the body, the larger will be the acceleration. So here, once the question talks about the smallest acceleration, then we must look out for the diagram that will give us the smallest net force. And it is when the angle between the forces is 180. Okay, please, are we okay? And so D is the option. All right. Question 4. Two forces are applied to a 2.0 kilogram block on a frictionless horizontal surface as shown. Now the magnitude of the forces F1. So this time we have a simple diagram. Okay, this is F2 8.0 Newton, then F1 2.0 Newton. The mass is 2.0 kilogram. The question requires that the acceleration of the block, we are determining the acceleration of the block and the direction. Start work. You are determining the acceleration of the block and the direction of this acceleration. 1 minute. This must even be 30 seconds because this is simple. Time is up. Oh, our time is up. Elegant. Elegant, go
Maybe I
ahead.
can run 3 meters per second squared to the right.
3 meters per second squared to the right. More views.
5 meters per second to the right.
5 meters per second to the right. More views.
The,
Agree, go ahead.
the third option.
The third option. What is at the third option, Agree?
3 meters per second squared to the right.
Okay, let's see. Elika, you want to come again?
No, please, it's the old one.
Okay. Then immediately the old hand.
Yes, please.
Okay, let's see. Once F2 is the larger force, but there's an opposition. Once there's an opposition, an opposing force, we can look for a net force. So the net force, yes, once F2 is greater than F1, the body accelerates in the direction of the larger force. Okay, so the net force would have to be F2 minus F1. So we have 8 minus 2, giving us 6. From Newton's second law, any force on a body can be determined by the product of the mass of the body and the acceleration. So the acceleration will be equal to the net force over the mass. And what is the net force? 6. What's the mass? 2. So 3.0 meters per second squared. The body would always accelerate to the direction of the larger force. So to the right or in the direction of F2. Let me see by hands those of you who got this. Okay. Okay. Great. Impressive. So that's it. Any question? No question. Any question? No question. Okay. So we looked at resolution of forces into components. Now the advantage, how do we use this? If I give you 3 forces, are you there? Or she's gone. I've given you this forces, 3 forces. This is F1. F1 has a magnitude of 10 Newton due east. Then there is another force of magnitude, so F1 rather. This is 15 Newton. This is acting at an angle of 45 degrees to the north. And there is a third force. Acting at an angle of 30 degrees of magnitude This is 25 Newton to this. The question is that determine the magnitude, determine the resultant force and the direction. Let me even add a fourth force, F4. The magnitude of F4 is 12 Newton. This is acting at an angle of 30 degrees from the north. Let me change something. Instead of writing this as 30, this makes an angle of 240 degrees from the y-axis. We are to determine the resultant, the magnitude of the resultant force, and the direction when these four forces act concurrently at the point. So this is a kind of question which would Yaba,
Mr. Please, what is the force of F3?
come in. So this is F3. F3, let me give it 20 Newton. Okay, so F1 is 15 Newton, acting at 45 degrees from the north. F2, 10 Newton, due east. F3, 20 degrees, acting at an angle of 240 degrees from the north. Then F5, F4, 12 Newton, acting at an angle of 30 degrees in an due from the north in an anti-clockwise direction. So we are to determine the resultant. All
Mr.
that.
Kedia,
Hello.
please, can you send the question to the platform?
Okay. So the first thing I want you to do for me is that I want you to help me resolve all the forces from F1 to F4 into components, into vertical, horizontal components for me. Okay, so that's your first assignment. Start with. So Akuya, the question is on the platform. Finished?
Yes, please.
Resolving the forces into the various components, I mean. Okay, so let's resolve the forces into their various components. So if we pick, let's draw a table. So F1, F2, F3, and then F4. So this is for X and then Y. For F1, what is its X component? Yes. What's the X component of F1?
10.6.
2 point what?
10.6.
10.6. Let's confirm. The angle it makes with the Y is 45. So it will be F1 sine 45 as against F1 cos 45. So 15 times sine 45 is root 2 on 2. Okay, so 7.5 root 2, the same value. Please, what is 7.5 times root 2?
10.6.
10.6.
Yes, please.
So this will also be 10.6. F2, yes. What did we get for the X component of F2?
10.
Yeah, that's 10. Then the Y component,
0.
good. F3, F3, the magnitude is 20 Newton, acting at an angle of 240. Okay, so 20 sine 240 and 20 cos of 240. Sine 240 is equal to sine 30. And sine 30 is half. So this is 10. The X component is 10. Then cos 240 is equal to negative of cos 30. And that will be negative of 0.866 times 20. Multiply 20 by 0.866.
Negative 17.32.
So negative 17.32, whereas the positive is X is 10. Then F4. F4 is equal to
Mistake.
12. Hello.
Please, we want to be negative.
Yes, please.
No,
Because 20 cos
it's negative. It's negative. Yes. It's true. So negative, negative.
And
F4.
the
Yeah, Yaba, go ahead. Hello,
I
Yaba.
was saying that the x component will rather be negative 17.22.
Let's
Like if exchange
let's confirm. The x component will be sine 240. And sine 240, this is negative, right? Sine 240, which is also the same as sine 30. So you have a input 20 sine 240. Let's see what that will give you.
negative 0.866.
Negative
Negative
0. Times 20.
So it will be negative 70.
Okay. So
Negative 70.
okay, so that will be minus 17.32 for the x and negative 10 for the y. But let's confirm, because I'm seeing the angle left is to the x zero. That is 240. What is the angle left? This is 30. Okay. So if this is 20, then this component, oh okay, Yaba, you are right. This component is 20 cos 30. And then this is 20 sine 30. Okay, thank you. F4. F4, the angle left to the x-axis is 60. So it means that the x component will be 12 cos 60 minus, and then 12 sine 60 to be positive. Cos 60 is half. So this is negative 6. And this is 12 by 6 root 3. What is 6 times root 3?
10.4.
I can't hear you clear.
10.39.
10.39. Good. So after resolving all the components into the vertical and then horizontal components, this is what we do. After doing this, find summation of all the x's and summation of all the y components. So sum everything up for me. So 10.6 plus this 20.6 minus 17.32 minus 6. What will that give us?
Negative 2.7.
Negative 2.
7.
So minus 2.72. Then what about summation of all the x, all the y's?
10.99.
10.39. Hold on. This is 0.6 plus this. Oh, this is 10. So it will be left with 0.6 when we subtract. So add 0.6 to 10.39.
10.99.
So 10.99 Newton. Okay. Good. So after summing up all the x's and all the y, let's redraw, represent whatever we've had so far on the Cartesian plane or xy axis. This is the x, this is the y. Now the summation of x is a negative value. So if we are to represent this on the xy plane or on this axis, it will act along this side. So this will be summation of x, which is 2.72 Newton. Then the summation of y, all the y is a positive value. So it will act, let me create space, a wider space rather. So we have summation of x's giving us 2.72 Newton. Then summation of the y is a positive value, which is also along 10.99 Newton. Okay, so we have two vectors, one along the x-axis and one along the y-axis. Okay, let's resolve to find the resultant of this and this. So by equal vector approach, we have this. Okay, so if this is in this direction and the summation of y is also here, then that, hello, you can
Please,
see.
can you have the screen? Yes, please. Thank
Yes.
you.
So we are only representing whatever we've had on the XY plane. Class, are you okay? Are you okay with what I'm doing?
Yes, please.
So if this is in this direction, this is here, then the resultant would act along the diagonal and will be here. So that will be the resultant of summation x and then the summation y we found. Okay, so we can use Pythagoras theorem because this part is perpendicular to this. R squared now is equal to summation of x squared plus the summation of y squared. Summation x is 2.72 squared plus summation y is 10.99 squared. R therefore is equal to the square root of 2.72 squared plus 10.99 squared. Please help me get the final answer. R will be equal to
11.32.
what? What? What's the value of R?
11.32.
11.32. So that's the magnitude. That's the magnitude. Then direction. You see, what's the direction? Look at the direction of the resultant. It's within the second quadrant. Okay. So let's find this angle. Maybe theta. So direction direction of the resultant. Because we have the opposite, we have the adjacent. When we take tangent of theta, tan of theta will be equal to the opposite, which is summation of y, over the adjacent, which is summation x. So this is 10.99 over 2.72. So help me determine this ratio. 10.99 divided by 2.72.
4.04.
1.04.
4.
Please 4.
4.04. Then theta will be equal to, take the tan inverse of what you have. The tan inverse of 4.04.
76.1.
76.1 degrees. What it means is that if this is 71, what will be this angle to the y? Don't forget 71 to the x. To the x-axis. What will be the angle the resultant makes to the y-axis? What angle would the resultant make with the y-axis?
13.9.
Come again.
13.9.
Okay, so that the angle, okay, will be 90 minus 76.1, which is 13.9. Thank you. So this is 13.9, approximately 14. So the direction of the resultant is 13 degrees anti-clockwise or counterclockwise from the north. Maybe if I'm at the north, I'm standing at the north, I have to turn through an angle of 13.9 degrees or approximately 14 degrees in an anti-clockwise direction to find the direction of the result. Anti-clockwise or counterclockwise, because in bearings we take angular measurements from the north in the clockwise direction. Please, are we okay? In bearings, we take our angular measurement from the north, but in a clockwise direction. So if we have to move anti-clockwise, you have to state it. All right. Please, are we okay?
Yes, please.
The other angle representation is that if I'm here, my resultant is along this direction. This is 70 what? When we calculate, what did we get for 70?
76.1.
Okay, so 76, meaning that the whole of this angle is 270. So 270 plus 76. Add it for me.
346.
346 degrees. Meaning when I'm here at the north, I can also turn through an angle of 346 degrees to face the resultant. So this is another possible angle. But the shortest is when you pick it from here. When you are at the same and when you are at the north and you go that 14 degrees anti-clockwise. Is that okay? Are we okay? So
Yes,
that's
please.
it. That's it. All right. Okay. So today we started a bit earlier than the normal time. So I'll leave it here and then send you a question. I'll send you a question to try. Okay. So let's end it here. I'll forward a question to the platform so you try. All right. Okay. So bye bye for today. We'll continue tomorrow. All right. Okay.
Yes, please.
All right.